Assalamu alaikum everyone. My name is Abdullah Haider and today I'll be covering chapter 10.5, which is the last section of chapter 10 of Laplace transforms. So in this section we'll be learning about unit step functions. So basically in unit step functions you have something like u t minus a is equals to now. Basically it's like 0 and 1, 0 and t is less than a and t greater than or equal to a, meaning like I have a step between two functions, 0 and 1, and if I want to represent this as a graph, assume we have something like this. This is 0, 1, this is 0, x, and let's say I take my a to be the origin here. So in this case, what this means is I will have an off state, basically like if you like think of it like switches. Before a, basically 0 means a switch is off, and by the way, there's going to be a hollow circle here. It's going to be a hollow circle here, and t 1 means 1 t greater than equals to a means I'll have something like this. Means a switch will be on at t is greater than or equals to a, and this is like how the graph looks like. So just to give you a general idea that a unit step function gives us having a function on or off. And in exam, you can get a question like express f of t in terms of unit step functions, where f of t is equal to 2 for this interval, so on. So what you have to do for these kind of questions is you first find the interval. You need to basically like find the intervals for the unit step functions, and this would be something like f of t is equals to a big bracket. You first put the intervals. So I have 3 less than or equals to t less than 5. This is done. Now this one. 5 less than or equals to t less than 8. And you can write this one as t greater than or equals to 8. And you simply write the functions. 2 t minus 2 and t squared. So we need to express f of t in terms of unit step functions. So a strategy to deal with this is your answer will be in form of 3 parts. This will be your part 1. This and this will form your part 2. This and this will form your part 3. So like this is 1, this is 2, this is 3. So what I mean by this is you need to answer based on the selection of A's. So basically, as we saw here, ut minus a. So we want to have something like ut minus 3 and ut minus 5, ut minus 8 for this question. So we need like three forms. So we start with the first one, which is in which a is equals to 3. So if you go to the Laplace transform table, you will see that you have some formulas, which one you will need. So for 10.5, we'll be focusing most on this one, and focus will also be on this formula. like the two main formulas we will use for this section. So basically, what we want is we want to put our expression in terms of u t minus a g of t. This expression only when you're asked to express in terms of unit step functions where you have your intervals given. So the first one. So we have let's take a is equal to 3. So u t minus 3 g of t. So g of t is basically all of the selections you have in this part. So you have u t minus 3, and this is multiplied by 2. And what you do is now plus. So you're done with a is equals to a is equals to 3. Now we move on to 5. So u t minus 5. Now important thing you need to note here is that since this 5 is in the middle of the interval, we need to know that we need to get the difference between this and this. Meaning like basically the function started at a is equal to 3. So u t minus 3 g of t will be by itself. Assume like this is this is the portion when a is equals to 3. This is the portion when a is equals to 5. This is the portion when a is equals to 8. So basically, if we take a is equals to 3 as the baseline, then g of t will remain the baseline. But since we've entered the middle of the interval, which is 5 and 5, because this is being repeated, so we need to subtract the second one by the first one. So I will write this as t minus 2 minus 2. Because I'm having a jump when going into a is equals to 5 from a is equals to 3. I have f of t to be 2 here, then I have t minus 2 here, then I'll have t squared here. So this is how you need to frame the question. We're done with our second A. We're done with 5, 5. And now we move on to 8. We're done with ut minus 3. We're done with ut minus 5. Now we need to move on to ut minus 8. So ut minus 8. Now our g of t, because when entering a is equals to 8, we need to have this form of jump from a is equals to 5 to a minus a is equals to 8. So we will subtract t squared by this. So this means t squared minus t squared minus t minus minus 2, so plus 2. And this is this is your expression. This is literally your expression. So like if you want to write the final answer, it will be 2u t minus 3 plus u t minus 5 t minus 4 plus u t minus 8 t squared minus t plus 2. This is your final answer, final expression. Now this is so this is basically like the best way to find an expression of the unit step function. Other ways, to be honest, if you look at ChatGPT, if you follow your prof, I'm sure you'll be a bit confused, but there's nothing to be worried about. And we will be testing our knowledge again on this question. So find the Laplace transform of the function f of t is equals to t minus 2 for this interval. So as I said before, always start with the interval. So f of t is equals to, now you have only 2, basically. So you have 3 less than equals to t t less than 5 and f of t, no, this will be 0 in this case. So otherwise, here we have t minus 2 and we have 0 otherwise. So I know it said start find the Laplace transform, but whenever you have these interval questions, you always need to start with finding the expression of the unit step function. So what you can do is one thing you need to know is let me just you have this interval 3 and you have this 5. So basically this is your a is equals to 3, a is equals to 5. And for this question, what we will do is we need to find our u t minus a g of t. So unlike the first part where you had 3 by itself and then you have 5 by 5 by itself and 8 by itself, we will like try to merge both a's into a single line. Because you don't have another interval containing 3, you don't have another interval containing 5. So we need to kind of merge them. And you start off by doing this. U t minus 3 minus u t minus 5. And you multiply the whole thing by your g of t. So in this case, what you can do is, so basically your expression would be, instead of the, g of t, just write t minus 2, to be honest. I need some space. So you subtract, if there's one interval only given by itself, then you do, this is a1, a2, so you do u t minus a1 minus u t minus a2 first minus the second one, and then you multiply by your f of, and then you multiply by your g of t, which is t minus 2. Okay, so this is our expression. So we multiply them. U t minus 3 t minus 2. And by the way, to be honest, it's better to keep the g of t on the left side. I'll explain later why. So we have t minus 2 u t minus 3 minus t minus 2 u t minus 5. Now what you do is you go to your Laplace table, and you can see that in the Laplace table you have this identity. So basically this is our expression of unit step function, but we need to find the Laplace transform. We need to find the Laplace transform of this unit step function. So you go to this one, u t minus a f of t minus a is equals to e power minus as f of s. So as you can see that u t minus a f of t minus a, here are a, we don't look at this t minus 2, we look at u t minus a, so this is your a. This is your a1. I just call it a. Okay. And then you have here ut minus a f of t minus a. You have u t minus a. This is your second a, and this is your f of t. But you might realize that here it's like u t minus 3, and then your f of t. Basically, your f of t is the function itself without the u function. So basically, u t minus 3, t minus 2. So you tell me that this number, this a is different, this a is different. So we need to fix this. We need to fix this expression. What I can do is I can, because I want my a to be 3, and here I want something which it's similar to a being is equal to 3. So what I can do is u t minus 3 and I can do 1, I think 1 plus 1 plus t minus 3. I think. Let me just check. Yeah. So 1 plus t minus 3. So now you can see that I have it in the form u t minus a f of t f of t minus a. So basically your f of t is 1 plus t, and your a is minus 3. Now I know you'll be feeling a bit confused here, but don't worry, we'll get the hang of it. So we have ut minus 3, 1 plus t minus 3. I can now write this as u t minus 3, 1 plus t. Wait, no, minus. Now we look at this one here. ut minus 5t minus 2. u t minus 5 t minus 2. So ut minus a f of t minus a. So your a is originally supposed to be 5, but we have a 2 here. We need a 5 in this place. We need a 5 in this place. So what I can do is I can write u t minus 5. If you add 3, so if you add 3 plus t minus 2, I'm thinking. I get it now. u t minus 5. So basically, how do you get from minus 2 to minus 5? You add, so how basically you need the difference. So 3 plus t minus 5. So what I have here is I have my ut minus a, I have my a correct, and this will be my f of t. To be honest, you need to do some you need to do some algebraic computation in mind to know what number to add here to make it negative 5. So this will be u t minus 5, 3 plus t minus 5. And now we have it in our form, which we can now use to find our Laplace transform. So e power minus as f of s. Now don't be fooled by this. F of s is the Laplace transform of f of t. So let me refresh this. So we have gotten in the form ut minus a f of t minus a. This is the form you always need to find the Laplace of a step function. So basically this was only to find the expression, but you need to use u t minus a f of t minus a to find the Laplace transform. Okay, so and this is equals to e power minus as Laplace transform of this f of t, e power minus as f of s. So if we bring, because there's really no space here, I'll use the table. So we have ut plus 3, 1 plus t minus 3, 1 plus t minus 3. So this matches the form u t minus a f of t minus a. So in this case, our a is, in this case, well, why is this plus? It's supposed to be minus here. U t minus 3, 1 plus t minus 3. So in this case, your a is 3, and your f of t, basically the number, the expression on the second bracket, but without the a. So in this case, you have 1 plus t. Now, basically, this f of s is basically the Laplace transform of this. You need to do the Laplace of 1 of t, and this is quite easy. The Laplace, you can see, of 1 is 1 over s, plus, and the Laplace of t is 1 over s squared. And this is on multiplied by e power minus 3s. So basically e power minus 3s, and then you do the Laplace of your f of t, and then you multiply. So in this case, your final answer is going to be, in this case, for this part, I know it's quite long. You can expect this question in the final. So e power minus 3s. It's up to you if you want to expand inside the bracket or not. E power minus 3s. E power minus 3s 1 over s plus 1 over s squared minus. Now we repeat the process for ut minus 5, 3 plus t minus 5. So then again, we'll be using this to find our Laplace transform. So u t minus 5, 3 plus t minus 5. This is our a, this is our a, this is our f of t. And so basically it's matching what we need to find our Laplace. So our a is 5, and your f of t is 3 plus t. Okay, so in this case, the Laplace transform of f of t, the Laplace transform of this is going to be, so a constant is going to be 3 over s. We're using this, and t, once again, we'll have to use 1 over s squared, so 1 over s squared. And now we multiply this by our e power minus as. So in this case, we have e power minus 5s, since our r is 5. E power minus 5s, 3 over s plus 1 over s squared. So I can write here e power minus 5s, 3 over s plus 1 over s squared, and this is your final answer for the whole question. And yes, I agree, this is long, even though you can say that this is just like 20% of an initial value problem question. To be honest, this is just 20% of an initial value problem question. We will see this. We will basically see this in the initial value problems which I will solve. But you can just imagine you need to know all these steps. So first of all, you need to find the unit step expression. First, write f of t is equals to brackets. And since there was only one interval, since there's only one interval, you do ut minus a1, basically the u expression for the first one minus the u expression for The second one, you multiply by g of t. So basically, this is for your expression, this formula, and this is for your Laplace. So we need to make sure that the year A's are matching exactly like how I explained before, and then you take the inverse, and then you take the Laplace using this formula. This is a simple one now. This is a simple one. So you have f of t is equals to brackets. You have two. So you have 2t minus 1 for the interval 0 less than equals to t less than 1. And you have t squared for t greater than or equals to 1. Same, I think nothing should change for this one as well. I don't think there's any difference. So you have this one. So you have this as your A1, and then you have this as your second aim. So we want u t minus a g of t for our expression, for writing our expression. So we'll begin with our first one. I know that this is a bit different from above because we had one single interval and a second was otherwise. But we have one interval which is 0 less than t less than 1, and we have t greater than or equals to 1. So we will deal with them. We basically need two forms of the u expression. So I can write this as ut minus 0 2t minus 1. And one thing you have to know is that u of t is basically is t minus 0 t, so u of t is always equals to 1. You need to remember this. U of t is always equals to 1. So in this case, you have 2t minus 1 remaining. We're done with this a, and now we move on to our a is equals to 1. So u t minus 1. And now you might remember from the first part, if you're making a jump in the unit step function from one a to another, and then you subtract the old f of t, you subtract your old g of t by the new one. So basically, this will be t squared minus 2t plus 1. And so now you can write your final expression. You can write your final expression as 2t minus 1 plus u t minus 1 t squared minus 2t plus 1 t squared minus 2t plus 1. So now what we do is you find the Laplace. So basically the Laplace of this is easy, but we will first look at this. We need to first look at the Laplace of this. And as I said before, when you want to find the Laplace, you need it in this form, u t minus a f of t minus a. So let's do this. You have ut minus 1t squared. You have u t minus 1 t squared minus 2t plus 1. So what you can do is, this can be actually written in terms of u t minus 1. You can actually rewrite this as t minus 1 squared. Just checking something. So now what you can do is you take this you basically let's say this. So you will be using this formula to find the Laplace. Your A is 1, but your f of t in this case, and this is kind of a special case, your f of t in this case is going to be t squared. It's really hard to it's really hard to give explanation of why it's t squared and not the whole thing inside. But just know that your A is 1. Basically, it's matching ut minus A, f of t minus A. This is your f of t minus A. We have a 1 here. But just know that since it's t minus 1 squared, so basically there's a square means there will be a square in the inside part as well. So your f of t is going to be t squared. And now we can use e power minus s and then the Laplace of t squared. So factorial over s2 plus 1 is 2 over s cubed. So e power minus s times 2 over s cubed. This is your So the Laplace transform of the function is e power minus s 2 over s cubed. And that's it for that question. And now we reach the most commonly asked questions in the quiz and the final, which is the ignition value problem. You will definitely get this in any quiz and final, you definitely get it. What changes is you'll have you'll have normal functions here. Sometimes you will have sine, cosine. Sometimes you will have an exponential as well. So we'll cover these cases. So as we discussed in 10.3, the first thing you need to do is take the Laplace of both sides. So Laplace of this, Laplace of this separately. So if we take the Laplace of the left-hand side, so you're doing Laplace of y double prime plus Laplace of y. Let's refresh this. You will be using this one, but this is in terms of y. Remember we did s square x. That was s, but x were but now we're dealing with y. So in this case, you'll have s square big y, s square big y minus s y small y of 0 minus y prime of 0 plus now y by itself basically is going to be your big Y plus big Y. So for now, you just deal with what you have on the left-hand side. So this means not substituting the initial conditions now. S squared big Y minus S. Now Y of 0 is -1 minus 1 plus Y. So this becomes S squared big Y plus S plus 1 plus Y. And you take the big Y as common, big Y S squared plus 1 plus S plus 1. So that for now, this is the mistake. Y prime 0 is 1. It's supposed to be 1 here. Supposed to be -1. -1, -1. So this is your starting. So basically, this is the starting point, which is the Laplace of the left-hand side. We're done with that, and now we need to find the Laplace of the right-hand side. So you have t minus 4 u t minus 2. Laplace of t. Now, Laplace of t is straightforward, but we need to focus on this one. This question is actually quite easy. To be honest, it would be really nice if you get such a question, but we need to deal with this unit expression. So you have t minus 4 u t minus 2. So if you want to find the Laplace, we need to make something. We need to have something in terms of this. So u t minus 2 t minus 4. Now we need to so basically our correct a is a is equals to 2. So we need an a is equals to 2 equivalent expression here. So what I can do is u t minus 2 should I add 2 or should it be -2? -2 plus t minus 2, yeah. So u t minus 2, -2, basically -2, -2, and -4. So basically you need t minus. So basically what I've been trying to say all this time is you need t minus 2, t minus 2, and like this will be matching, and this will be your f of t. This will be your f of t, and this is your a, this is your a. So now you can like find the Laplace of this easily. So in this case, the a is 2, f of t is -2 plus t. And the Laplace should be f of s should be 6 to minus 2 over s plus you should be now familiar with these formulas without even looking at the table. So now, simply put, this will be e power minus 2s minus 2 over s plus 1 over s squared. So now we can write here the Laplace of this is going to be e power minus 2s minus 2 over s plus 1 over s squared plus 1 over s squared. All right. And basically now you equate them. Now you equate this and this expression to each other. So now you get y s squared plus 1 plus s minus 1 is equals to e. Now it's actually better to expand. Yes, also mine. So minus 2 e power minus 2s over s plus e power minus 2s over s squared. So now what you need to do is you need only the y here. You only need the y by itself. So what I can do is simply y is equals to, I take this to the right side. I take 1 minus s minus 2e power minus 2s over s plus e power minus 2s over s squared, and multiply no, divide everything by s squared plus 1. And like I think it's better to keep them. I think it's better to factor e power minus plus again, to be honest. So the whole thing will now be divided by s squared plus 1. So I can write this as 1 over s squared plus 1 minus s over s squared plus 1. It's better to factor it out. Minus e power minus 2s 2 over s plus 1 over s squared. To be honest, it's better to keep it like this, over s squared plus 1. Let me just see if everything's fine. Oh, 1 second, 1 second. We forgot to take the Laplace of t. We forgot to take the Laplace of this. Damn. So Laplace of this t, my bad, was my bad. So Laplace of this t is 1 over s squared minus the rest of this. So we have to I guess we have to go back a bit. You can see how much these small mistakes cost. Alright, so now you have found the inverse. Now that since you have found the Laplace of t minus 4 ut minus 2, now what you can do is you can find the Laplace of this t, and the Laplace of this t is going to be 1 over s squared. So 1 over s, so basically the Laplace of the whole right hand side is going to be 1 over s squared minus e power 2 minus 2s multiplied by this bracketed side. Now we can equate them. Now I can equate them. Now we can say y s squared plus 1 plus s minus 1 is equals to 1 over s squared minus e power minus 2s 2 over s plus 1 over s squared. Okay? So now basically, as our objective was before in 10.3, we wanted the big X on the left side by itself. So that we are going with only the big Y on the left side. So I can do this like y s squared plus 1 is equals to 1 minus s plus 1 over s squared minus e power minus 2s 2 over s plus 1 over s squared. And this is supposed to be negative, minus 2 minus 2. And now we only need y, so y is equals to 1 over s squared plus 1 minus s over s squared plus 1 plus 1 over s squared plus 1 minus e power minus 2s 2 minus 2 over s plus 1 over s squared, all this divided by s squared plus 1. Yes, this is kind of hell. So we need to take the inverse Laplace of the whole thing. We take the inverse Laplace of basically the whole thing. Inverse Laplace of the big Y and the inverse Laplace of this whole expression. Inverse Laplace. So getting the inverse Laplace of this is easy. This is easy. Let's first focus on the easy part. Inverse Laplace of 1 over s squared plus 1. So this is similar to saying k over s squared plus k over s squared plus k squared. So this matches 1 1, so your k is basically 1. So this is basically the inverse of this is sine t. That our first part is done, and now we need to find the inverse Laplace of s over s squared plus 1 is equals to, now we go find something like s over s squared plus k squared, which matches this one, cosine kt, and since it's like k is 1, k is 1, so cosine 1t, so which is cosine t. And remember that when you're adding up the final answer, remember that this should be negative because this is minus s over s squared. So remember, this should be negative when you're adding the final answer. So we need to find the inverse Laplace of this. Inverse Laplace of 1 over s squared plus 1. Yes, this is going to be long. This will be involving partial fractions. If up till now you were not expecting that, well, it has arrived. And you should know that 1 over s squared plus 1 is the same as as, should be as plus b over s squared. No, 1 second. Yes, check something. Yeah. So this should actually be, because in calculus 2 you might have learned that we start from the lowest degree because we have an s by itself, so this should be a over s plus b over s squared, and this is unreducible, so cs plus d over s squared plus 1. So you get 1 is equals to a s squared plus 1 plus b s squared plus 1 plus cs plus d divided by x squared only. So we expand. You might remember we can expand. 1 is equals to as cubed plus as plus bs squared plus b plus cs cubed plus ds squared, and then you group the similar exponents, meaning 1 is equal to a plus c s cubed plus b plus d squared plus as itself as plus b. So you might remember that since we don't have sq on the left side, a plus c is equals to 0. There's no s squared on the left side, so b plus d is equals to 0. There is and there is no s on the right side, so in that case as is equals to 0. And so in that case you also get that a is equals to 0. And 1 being basically constants matching, so b is equals to 1. So if a is equals to 0, meaning c is also 0, b is 1, then d is negative 1. So these are your coefficients. So the inverse of this is going to be a over s. So a is 0, so this thing is gone. C is 0, so this thing is gone. So we're left with b over s squared, so b is 1. So we're left with the inverse Laplace of 1 over s squared plus now d over, now this is going to be negative because d is minus 1. So d is minus 1 over squared plus 1. Inverse Laplace of 1 over s squared is basically t. And 1 over s squared plus 1, this is basically the same as this. So t plus sine t. No, this is supposed to be negative. So 1 over s squared minus, so this is supposed to be t minus sine t. This is only 80% of the work done. We have this remaining. So it's getting quite long, actually. So now we need to find the inverse Laplace of this thing. We need to find the inverse Laplace of this thing. Let's thinking of something. So first, let's rewrite this. Laplace inverse of e power minus 2s multiplied by minus 2 over s plus 1 over s squared plus 1 over s squared, all divided by um, s squared plus 1. Now, one thing important to note here is whenever you have e power to do something, remove it from the partial fraction. So in reality, what you want to find, so you'll be finding the partial fraction again, but you keep this until the last step because this is a transformation technique. So minus 2 over s, what you're left with is minus 2 over um, just take this take this fraction down. So this will be minus 2 over s squared plus 1 plus 1 over 1 over s squared plus 1, and you need to find the partial fractions of these two again. I think we did 1 over s squared plus 1. 1 over s squared plus 1. This is already done. We have good news, 1 over s squared plus 1. So the inverse Laplace, basically the inverse Laplace of this is going to be t minus sine t. So this is good news we have. So this is t minus sine t, but something special done on this. So we need to find the inverse Laplace of this means we need to split this into newer partial fractions. So minus 2 over s squared plus 1 is equals to now a over s plus bs plus c. This is s. bs plus c over s squared plus 1. So minus 2 is equals to a s squared plus 1 plus bs plus c, this multiplied by s. So minus 2 is equals to a squared plus a plus bs squared plus cs. We group these terms together, so minus 2 is equals to a plus b s squared plus cs plus a. And we don't have an s squared on the left side, so a plus b is equals to 0. We don't have uh, um, an s. We don't have an s on the left side, so c is equals to 0, and this gives us c is equals to 0. And finally, minus 2 is equals to a because constants match constants. So A is equals to minus 2. In that case, if you're using this equation, B should be 2. So minus 2 plus 2 should be equals to 0. So we have our A, we have our B, and we have our C. So the Laplace um, Laplace inverse of so right it here. So this will be equals to minus 2 over S C is 0, so this is 1 plus BS. So 2S over S squared plus 1. Now that the Laplace should be easy of this. Laplace of 1 over S is T, so minus. So this thing will give you minus 2t. So Laplace of 1 over s is t minus 2t. And s over s squared plus 1, you should know it by now. S over s squared plus 1 cosine t minus 2t plus cosine t. I'm just checking something. Oh no, of s. There's no t. There's no t. My bad. It's t when if it's t when it's 1 over s squared, but we have it in 1 over s, so it's minus 2 by itself. So this so for this thing alone, we have t minus sine t, and we have 2 plus cosine t. Now you will let me just confirm these are right. Let me just confirm that. Oh, and this should be plus 2 cosine t. Oh, I'm doing so many mistakes today. Minus 2 plus 2 because we have a 2 here, and this should be multiplied by cosine t. So this we're still not done with this part alone. I know. I hate it. We need to apply something called the shifting theorem. We need to apply the shifting theorem because we have this e power minus 2s. We need to apply the shifting theorem. So what I mean by shifting theorem is we will basically be using which one was it again? If you go back to the original, everything else, your original a is from this a unit expression, your a is 2. So we need to apply the u t minus 2 transformation on the answer, meaning wherever I have, so basically the Laplace of this, so basically the answer of this is going to be u t minus 2. You need to say this because look, basically your a is 2. Even you can look you can look at your exponent as a is 2. So whenever you have an exponential to power something, you need to apply the shifting theorem, which says that ut minus 2, basically ut minus 2, your a, and your whole answer, and whatever you have, wherever you have t in your answer, replace it by t minus 2, and this applies only for the Laplace of this thing. So basically, the answer was t minus. So originally it was t minus sine t minus 2 plus 2 cosine t. Now we will substitute t minus 2 everywhere in this answer. So this ut minus 2 will be multiplied by, so instead of t, I'll write, instead of this t, I'll write t minus 2 minus, now instead of this sine t, I'll write sine t minus 2. Now this is done, this is done. Minus 2 will stay the same, minus 2 plus 2 cosine. Now instead of this t, I write t minus 2. And that's it. So as I was discussing right now, that once you get your answers, for these separate forms, like the answer for this was t minus sine t, and the answer for this based on the partial fraction was minus 2 plus 2 cosine t, you will be applying whenever you have an e power minus 2, e power s, or anything. So you will basically write ut minus a, whatever a was here, ut minus 2. And then for these answers, you'll put them in a big bracket and replace t wherever you have t in this answer by t minus 2. So basically, this was like overall the answer. We can replace it by t minus 2. Finally, let's forget this. Finally, we'll be combining our answers. So now what we can say is our final answer y is equals to, now we go back to all our inverses which we did. It started from here, right? Yeah. So the inverse, so this was our overall main equation, our main big equation. So we found the inverse 1 over s squared plus 1, which is sine t. So we'll go down. We'll go down and write right here sine t. All right, this is done. Now we'll go with s over s squared plus 1 cosine t, and as I said before, remember that we had a minus here, so this would be minus cosine t. Sine t minus cosine t, and plus 1 over s squared. So we found this to be t minus sine t. Go down, plus, right, t minus sine t, plus t minus sine t. And so this is done, and minus this part. So basically minus all this answer. So simply minus ut minus 2, and this ut minus 2 is multiplied all together by t minus 2 minus sine t minus 2 minus 2 plus 2 cosine t minus 2. This is so long, I'll be honest, this is so long. Let me just confirm my answer. And like this, so this is like the final answer of the whole Laplace question. Basically, the final answer. Look at all these steps, it's so long. And just cancel out sine and minus sine, and the rest is your answer. The rest is your answer. You can also do t minus 2 minus 2 t minus 4. Yeah, and rest is correct. This is the answer to this question. It's long. It's really, really long. Oh my god. It's so long. Okay, so now we'll move on to this. Same thing as always, you take the Laplace of both sides. So Laplace of y double prime plus Laplace of plus 4 the 4 multiplied by the Laplace of y. Let's first do this. we've seen many times how this will work. S squared big Y minus sy of 0. By now you should actually memorize it. No need to look at the table. Minus sy of 0 minus y prime of 0 plus 4, and then y is by itself, so 4 big Y. So substitute the initial conditions: s squared big Y minus s minus s minus 1 minus 2 plus y. And now you can simply, I'll try to now speed up, to be honest. Now you should get the point of what you should be doing on the initial value problem question. So s squared plus 1 plus s minus 2. Mm, S squared plus, 1 second, s squared. Oh, I'm making mistakes. My bad. It's been quite long. So s squared, okay, plus 4y. So we're combining the big y's. So y squared plus 4 plus s minus 2. The left side part is done. This is 2. And now we'll deal with sine t. Now the left hand side is done. Now we'll deal with the right hand side. Now on the right hand side you have sine t minus u t minus pi over 2 cosine t. We need to take the Laplace. We need to take the Laplace of the side. So the Laplace of sine t. What is the Laplace of sine t? K is 1. So 1 over s squared plus 1 squared. So 1 over s squared plus 1. 1 over s squared plus 1. Okay. And now we'll deal with this unit step function again. So we have ut minus pi over 2 cosine t. Let's do it here so to save more space. So you have t, so ut minus pi over 2 ut minus pi over 2 and cosine t. So basically our goal is to get something like u t minus pi over 2. We need so basically your real a is pi over 2. So somehow we need to fit that pi over 2 in the cosine. Based on what we have here, we need to find the Laplace of ut minus pi over 2 cosine t. And so these are important identities you need to memorize, and later on you'll find out why. So we need to make this into proper ut minus a f of t minus a, because otherwise we cannot find a Laplace. So we need to fit pi over 2 here somewhere. So I can write this as ut minus pi over 2 cosine t minus pi over 2 plus pi over 2. So I advise. So basically, this is how so basically you write t minus 2 pi, 2 pi, and then add something to it which will make it so basically add something which will cancel out. Okay, now you will apply the you will apply the cosine rule here, assuming this is your A and this is your B. So when you do cosine A cosine B means cosine t minus pi over 2 cosine pi over 2 plus sine t minus pi over 2 sine pi over 2. So you should get something like is the formula wrong or something? Addition of cosines. Oh, addition of cosine. We're using this formula. Addition of cosine A plus B. So here, this should be a minus. My bad, guys. I'm tweaking today. Minus. So cosine pi over 2 is 0. Means this will become 0. And this is equals to, so basically this is equals to 1. So in the end, you'll get minus sine t minus pi over 2. So we've managed to fit our t minus pi over 2, and it doesn't matter if we converted the cosine to sine. Sometimes you don't have to convert from cosine to sine. Like it depends on the numbers and the question. So now we can write as minus sine t minus pi over 2. So u t minus pi over 2 multiplied by minus sine multiplied by this. So now we can say that we'll finish it here. So minus u t minus pi over 2 sine t minus pi over 2. You have a is equals to pi over 2, and your f of t basically without the a is sine t. F of t is sine t, and I speed up, to be honest. F of s is going to be sine t, sine t, sine t. This is supposed to be sine t is hidden. 1 over s squared plus 1. 1 over s squared plus 1 squared. So you should have e power minus pi over 2s multiplied by 1 over, and this is minus, by the way, because you have a minus sign here, so you have to put a negative sign. 1 over s squared plus 1. So the inverse, so the Laplace of this whole thing is mine. What is this? Minus e power minus pi over 2s. 1 over s squared plus 1. Let me check if everything is good. Yes, correct. So now what we do is we like rearrange everything into one main equation. So y s squared plus 4 plus s minus 2 is equals to, now we have the Laplace of sine t, which is 1 over s squared plus 1. So minus, now remember the Laplace for this Laplace for this was minus, so minus should be a plus e power minus pi over 2s 1 over s squared plus 1. And you know what to do now. Y s squared plus 4 is equals to 2 minus s, you're taking this to the right side, plus 1 over s squared plus 1 plus e power minus pi over 2s, pi minus pi s over 2, 1 over s squared plus 1. And now what you do is you divide everything by s squared plus 4. So y is equals to 2 over s squared plus 4 minus s over s squared plus 4 plus 1 over s squared plus 1 s squared plus 4 plus e power minus pi s over 2 multiplied to the inside. 1 over s squared plus 1. There's a good thing about this question, by the way. In the end, you'll notice. So this is our main big equation, and now we need to find the inverse Laplace of this main equation. Inverse Laplace. So inverse Laplace of this is what? This is inverse Laplace of 2 over s squared, means you're looking for something k over s squared plus k squared, 2 over s squared plus 2 squared. So this will be sine, so k is 2, sine 2t. Inverse Laplace would be sine 2t. Now the inverse Laplace of s over s squared plus 4. S over s squared plus means 4 means 2 squared, and this one, yeah. So this will be s over s squared plus k squared. So k is 2. K is 2 means cosine 2t. So we'll write minus cosine 2t. And there's something good about this question. I will discuss what the good thing there is in this question. So the inverse of this is found. Inverse of this is found. Now we need to find the Laplace inverse of 1 over s squared plus 1 s squared plus 4. Partial fractions. You can write this as 1 over s squared plus 1 s squared plus 4 is equals to, now s squared, x squared, these are not, these cannot be factored and they're squared, so as plus b over s squared plus 1 plus cs plus d over s squared plus 4, and you have 1 is equals to as plus b s squared plus 4 plus, what will this be? cs plus d multiplied by s squared plus 1. So you expand, this is all in brackets, plus, so 1 is equals to as cubed plus 4as plus bs squared plus 4b, this is might be long of it, plus cs cubed plus cs plus ds squared plus d, and you combine all the terms, so 1 is equals to a plus c s cubed plus b plus d squared plus 4a plus c multiplied by s. We have only 1, 2, 3, 4, 5, 6, plus 4b plus d. So no s cube on the left side, so a plus c is 0. no y square on the right side, no y square on the left side, so b plus d is equals to 0. There's no s on the left side, so 4a plus c is equals to 0. 4b, and then constants match constants, so 4b plus d is equals to 1. So from here you can take c is equals to negative a. So 4a minus a is equals to 0. A will be, so a will be 0, and means c will be also equals to 0. So c is 0, a is 0. B plus d is equals to 0. So b is minus d. So b is equals to minus d means minus 4d plus d is equals to 1. D is, so this is minus 3d is equals to 1. D is minus 1 over 3. B is 1 over 3. So now you can find the Laplace inverse. So Laplace inverse of this is going to be a is 0, c, a is 0, c is 0. So this is gone, this is gone. B, what is our B? 1 over 3. 1 over 3 multiplied by 1 over s squared plus 1 plus now d, our d is minus 1 over 3 plus 1 over, minus 1 over 3 multiplied by 1 over s squared plus 4. So we need the inverse of, we need the inverse of 1 over s squared plus 1 and 1 over s squared. So 1 over s squared plus 1, 1 over s squared plus 1, this will be sine t. This should give you sine t. And this should give you, so 1 over s squared plus 4, 1 over s squared plus 2 squared. This will be, wait, yeah, this one, but there should be a 2, so this should be 1 over 2 multiplied by sine 2t. Why? Because you have k equals to 2 here, k is equals to 1, so you need to write something like 1 over 2 multiplied by 2 over s squared plus 2 squared to match the case. So this will be 1 over 2 times sine 2t. 1 over 2 sine 2t. And the Laplace inverse of this partial fraction is going to be 1 over 3 sine t. 1 over minus 1 over 3 times, times 1 over 2 is minus 1 over 6 sine 2t. Yeah. Okay. Now I'll tell you the good part. We have the inverse of this one. We have the inverse of this one. We have the inverse of this one. Now we need to find the inverse of this. So e power minus pi over 2s. This is, and inside you have 1 over s squared plus 1 s squared plus 4. 1 over s squared plus 1 s squared plus 4. So the good thing is you already have the overall answer for this part. You already have the overall answer for the inverse Laplace of this, which was 1 over 3 sine t minus 1 over 6 sine 2t. 1 over 3 sine 2t. Oh no, it's only t. 1 over 3 sine t minus 1 over 6 sine 2t. 1 over 6 sine 2t, yeah. So you already have the inverse, you already have the inverse of this partial fraction, and now we need to apply our transformation. So meaning u and then t minus whatever a you have. So uh, t minus pi over 2, and then you replace and then you replace this by t minus pi over 2, t minus pi over 2. So you'll have 1 over 3 sine t minus pi over 2 minus 1 over 6 sine 2 t minus pi over 2. And so this is your answer for the inverse of this. And this answer, so basically this whole big answer is separate from this answer. So don't get confused about it. This answer separate, this answer separate. So finally, we can write our final solution. Y is equals to, now what was the inverse of this? Sine 2t. Sine 2t minus cosine 2t minus cosine 2t. So this is done, this is done. I'll use orange now. So this is done, this is done. Now the answer for this, which was 1 over 3 sine t minus 1 over 6 sine t plus 1 over 3 sine t minus 1 over 6 sine 2t minus 1 over 6 sine 2t plus the e power this thing. So plus this answer, u t minus pi over 2 all multiplied by 1 over 3 sine t minus pi over 2 minus 1 over 6 sine 2 multiplied by t minus pi over 2. This is your final answer. Let's see if it's correct. Let's hope I did not do anything wrong. I'm hoping. Okay. Till now it's fine. I'm correct. Yes. So this is, oh my God, this is the final answer. This it is so long. It's so long. All right, so we've done these two initial value problems. This had general TS. It had more partial fractions. This one had a cosine, and then you have to use the identity. You need to be aware of the identity which I used that time. And now we'll move on to our last case of initial value problems. Let's just get done with this row. So then again, take Laplace of both sides. So Laplace of the Laplace of double prime s big Z minus sz of 0 minus z prime of 0 plus 3. Now what is z prime? F of t plus 3 sz as the big Z minus s minus z of 0 plus 2 big Z. So now substitute the initial conditions. S big Z minus S. So this will be 2S minus 3, so plus 3 plus 3 s big Z minus 2 plus 2 Z. So combine no, let's first expand this a bit more. Sz minus 2s plus 3 plus 3sz minus, now this is a 2, so minus 6 plus 2z. Now combine all the z's. S big Z plus 3s big Z plus 2z 3 minus 6, so 1 minus 2s, so 3 minus 6 minus 3. I hope I did not do any mistake here. I'll check in the end. So z s plus 3s plus 2 minus 2s minus 3. So z 4s plus 2 minus 2s minus 3. Let me check if this is correct. It's supposed to be square. Well, s square z, s square z, s square z, s square z. So z s square plus 3s plus 2 minus 2s minus 3. Yes, this is correct now. So we're done with the left side. Now we put our focus on the right-hand side. So let's use this one. We need to find the Laplace of u t minus 2 e power minus 3t. We need to find the Laplace inverse of this one. So in the end, we want something which has u t minus 2. We want something which has e power t minus 2. All right. So we need to have something like that. And how can you do this? There's a lot of you need to do some thinking a lot about this. So let's first do this. You have this. So what you do is you substitute minus 3 t minus 2. So you basically put, instead of t, you put t minus 2. Okay. And what you're left with is u t minus 2 e power minus 3t multiplied by e power 6. Okay. And if I want so basically comparing this to this, I need to multiply by something which will get rid of the e power 6. So I can multiply this by e power minus 6. If I multiply e power 6 and e power minus 6, I'll get this as it is. And now what I can say is what I can say is we will keep this as we will keep it like this. So for now For now, keep away the e power minus 6 outside. U t minus 2 e power minus 3. Now this is the same as this. So basically, e power minus 3 t minus 2. I think now it's fine. We have ut minus 2. So our a's are matching. Our a is 2 basically. And your a is 2 and your f of t. Your f of t is, so your f of t is going to be, in this case, e power minus 3t. You take you literally take the f of t apart from this 2 over here. So f of t is e power minus 3t. And if you want the Laplace of this, it's going to be, oh, we already here. So a is minus 3. So 1 over, we'll use this one. So s minus 3 is s plus 3. So our final answer in this case is going to be, and we will use this one as well. So e power minus 6 multiplied by, or e power minus 2s 1 over s plus 3. So I'll have a short recap. So we had ut minus 2 e power minus 3t, and we substitute t minus 2 here to have something which is related to t minus 2 because our a is 2. And we get e power minus 3t multiplied by e power 6, and you have to multiply by e power negative 6 to cancel this out. But in reality, you don't cancel it out. You take out the e power minus 6 outside, and you have e power minus 3t minus 2, a is 2, and your FFT is basically e power minus 3t. This is what you get. So the Laplace transform of the right-hand side. So from here you can write is equals to, this is equals to e power minus 6 e power minus 2s 1 over s plus 3. And you do z s squared plus 3s plus 2 is equals to 2s plus 3 plus e power minus 6 e power minus 2s 1 over s plus 3. Divide everything by this fraction, this this polynomial. So 2s over s squared plus 3s plus 2. Can this be factored, by the way? Yeah, it can, but let's wait. So over 3 over s squared plus 3s plus 2 plus e power minus 6 e power minus 2s 1 over s plus 3 s squared. I'm starting to get fed up of this. So now this is our main big equation. This whole thing is our main big equation. We need to find we need to find the Laplace inverse. And we can actually combine these two together. I'm not sure why I did not realize it before. You can combine this together and write 2s plus 3 over s squared plus 3s plus 2. And this is also the same as 2s plus 3 over s plus 2 s plus 1. Okay, so now you'll be using the partial fraction decomposition method here. 2s plus 3 is equals to, so this is also equals to a over s plus 2 plus b over s plus 1. So a s plus 1 plus b s plus 2. This is a very easy partial fraction. So if s is negative 1, if s is negative 1, so 1 is equals to b, so b is equals to 1, and if s is equals to negative 2, then minus 2 times 2 minus 4 minus 4 plus 3 minus 1 minus 1 is equals to minus a, and a is also 1. Interesting. Yeah, it's correct. So you have 1 over s plus 2 plus 1 over s plus 1. You can take now the inverse of this, so the inverse of 1 over s plus 2 means that your a is minus 2, and you'll be using this one. So this will give you e power minus 2t, plus now this is a is equals to 1, a is equals to minus 1. So e power minus t based on this one. Okay. Now for this one, we have this left. So let's do this one. Let's do this on the new. Let's do it here. Um, all right. So now you need the partial fraction of e power minus 6, e power minus 2s, and you can split it from the inside, so 1 over s plus 3. Since it's like the same polynomial, so you can write s plus 1, s plus 2. So as you can see here, you have an exponential, and you will be applying the transformation method. So this will be 1 over s plus 3. All this big thing is going to be s plus 1, s plus 2 is a over s plus 3 plus b over s plus 1 plus c over s plus 2. And you'll get 1 is a s plus 1 s plus 2 plus b s plus 2 s plus 3 plus c s plus 1 s plus 3. This is so long. So if you do s is equals to negative 3, if you do s is equals to negative 3, negative 3 means this thing, this will be 0. This will be 0, so 1 is equals to a, let me do this. 1 is equals to a minus 2 minus 1. So 1 is equals to 2a. A is 1 over 2. Now if I do, s is equals to negative 2. Negative 2 means 1 is equals to, if I take it, if I take it corresponding to what I have above, so 0 plus 0 plus, now I substitute negative 2, so c minus 2 plus 1 minus 1, 1. So I'm left with 1 is equals to negative c, so c is equals to negative 1. Now last thing left, s is equals to negative 1. Negative 1, 1 is equals to negative 1 means this is 0, the last thing is 0. So 0, 0, what I have in the middle? B minus 1 plus 2 is 1. Minus 1 plus 3 is 2. So 1 is equals to 2b. B is 1 over 2. With 2. So a is half. I'm just checking if it's right. So this plus 2, C. Okay. Yeah, it's correct. So based on what we have gotten, so we have 1 over s plus 3, 1 over s plus 3, no, 1 over 2 multiplied by s plus 3, 1 over 2 multiplied by 1 over s plus 3, plus, now b, what is b? 1 over 2 multiplied by 1 over s plus 1. C is negative 1, so minus 1 over s plus 2. So if I do the inverse of these, if I do the inverse of all of these, I'll get 1 over 2 e power minus 3t plus 1 over 2 e power minus t minus e power minus 2t. And let me just check if this is right. Yeah, it's right. And since this was multiplied by this thing, what was our a? What was our a related to this? Our a is 2. Meaning I have to do t minus 2 everywhere. So in this case, t minus 2 means this whole answer I need to do minus 2. So 1 over 2 e power minus 3 t minus 2 plus 1 over 2 e power minus t minus 2 minus e power minus 2 t minus 2. This is the answer only for the inverse of this part. And now we will make our grand answer and get finished with these initial value problems. So for this one, for the first one, we had e power minus 2t plus e power minus t. So z is equals to e power minus 2t plus e power minus t. We're done with this. And we're also done with it because we merged them. Plus this one, and the answer for this was oh, and I also forgot we had to multiply this by e power minus 6 as well. E power minus 6 because there was an e power minus 6 as well. So the transformation is being done based on this e power minus 6 u t minus 2 1 over 2 e power minus 3 t minus 2 1 over 2 e power minus t minus 2 minus e power minus 2 t minus 2. And this is the final answer. So this is the final answer of the whole thing. So we've discussed initial value problem of this, we've discussed the initial value problem of this thing, we've discussed the initial value problem of this thing. For those with Khalid's quiz, you can stop at this point because this is until this point you need to know for the quiz, but for the final you need to know all of this. For the final you need to know the rest of this. I need to plug my charger. So we'll move on to this. Find the inverse Laplace transform of the function. So I've done many things today. I've done many things today, but if there is one thing that could also let you down in the final or the quiz, not for this semester's quiz, for any quiz after this semester, which means any quiz starting from the fall 2026 quiz. These three questions are not only these three questions. All of these questions are going to be your enemies. They're going to be your enemies. Wallah. So find the inverse Laplace transform of the function. It's actually kind of exactly the same idea. It's actually literally the same idea of what we did in the initial value problems. But let's see. I think there is something which should be of interest here. So we will ignore the e power minus s and we'll do the partial fractions of this. So you get 3s squared plus 5s plus 5s plus 2 over s minus 1 s squared minus 4s plus 13. And you can write this as a over s minus 1 plus b s plus c. By now you should know why. S squared minus 4s plus 13. So same like what else should I say? It's like the same thing what you have been doing up till now in the partial fraction section. 3s squared plus 5s plus 2 is equals to a s squared minus 4s plus 13 plus bs plus c, this multiplied by s minus 1. So 3s squared plus 5s plus 2 is equals to as squared minus 4as minus 4as plus 13a plus, now what was this again? This is s, yeah. bs squared minus bs plus cs minus c. So now you might have realized that in the past we literally had, like, in the past, what we had. So we only used to have a 1 or only a constant where you don't have s cubed, s squared. But in this part you have, so in this part you have, and then basically this also means you have to do more calculations. So you have 3s squared, as squared, bs squared. So what you can do is, let's first group them. 3s squared plus 5s plus 2 is equals to a plus b s squared. Now the s plus, now minus 4a um, minus b plus c s plus, we only have a constant now, 13a minus c. So this is what you get after you group them. So 3s with a plus b means 3 is equals to a plus b, and 5 is equals to minus 4a minus b plus c, and 2 is equals to 13a minus c. Interesting. So this is all this. You can use your calculator, to be honest. You can use your calculator now. The unknowns. So after all this, you get a is equals to 1, b is equals to 2, and c is equals to 11. So this means now the partial fraction becomes 1 over s minus 1 plus 2s plus 11 over s squared minus 4s plus 13. Now we're not done. We're not done. Hold on your horses. You can get an inverse for this. Inverse for this is going to be e power t, e power minus t, right? Or no, yeah, e power t. A is 1. We still have to find an inverse for this. Can this even be factored? No, I don't think so. So we'll have to use the completing the square method for this. So 2s plus 11 over s squared minus 4s plus 13. We'll have to do completing the square. So 2s plus 11 is equals to s minus 2. It was s minus 2 squared plus 9 plus 13. No, plus 9 plus 4. In whatever way you do the partial fraction, you should get plus s minus 2 squared plus 9. And now what you can do is 2 s plus 2 plus 7 over mm, mm, oh, s minus 2 needed above. 2 s minus 2 minus 4 from minus 4 to 11 you have to add 15 s minus 2 squared plus 9. So now you have 2 s minus 2 over uh, s minus 2 squared plus 9 plus 15 over s minus 2 squared plus 9. Now you can easily do the inverse Laplace of this. You go, I think here, yeah. S minus A, S minus A. S minus A over S minus A squared plus K squared. Sorry, A is 2. Your K is 3. So this will give you, we're using this one. 2a power 2t, 2a power 2t, cosine 3t, cosine 3t, plus now this one, now for this second one we'll use this one. And this should be 15 plus 15 e power 2t. 15, why is it 15? Oh, 1 over 3. Basically, yeah, 15 s minus 2, 15 multiplied by I'm getting tired, to be honest. I'm getting tired. 15 over 1 minus s minus 2 squared plus 9. So k is 3. You're supposed to have a 3 here, but then you divide this by 3. So that is why you multiply by 1 over 3, so there should be 5. 5 e power 2t sine 3t. And this is the inverse. This is the inverse of. So this is the inverse of the partial fraction. And in case you haven't noticed yet, we need to apply our transformation. A is 1. So basically e power minus 80. So a is 1 here. Means you will have to do u t minus 1. So u t minus 1. And then replace everywhere t by t minus 1. So 2 e power 2 t minus 1 cosine 3 t minus 1 plus 5. I can't wait to get done with this. 2t minus 1 sine 3 t minus 1, and the whole thing is done. This is the answer for this question. Inverse Laplace transform of the function. There should be an easy way to do this. And by the way, I just want to save my time. All of this is do it yourself. This came in the spring 2026 final. These two questions came in the spring 2026 final. All this is do it yourself. I really can't go through every single one of them. I'm getting tired, wallah. Okay, so for this question, what you can do is um, how did I do this before? Oh, okay. I got it. So what you'll do is, since you have an S minus, so you can actually do this like if you want, you can do this like S cube over S minus 2 power 4. You can do it is the same as A over S minus 2 plus B over S minus 2 squared plus C over S minus 3 S minus 2 cube plus D over S minus 4 by 4. And you know the rest of the drill. You know you can do this. You can do the rest of this yourself. And the same applies to this. Because I'm tired of partial fractions of the day, but I'm giving you just a hint of what to do. So S cube over S squared plus 1, S squared plus 9, same idea. You can do this as AS plus B over S squared plus 1 plus CS plus D over S squared plus 9. And you can simply use the partial fractions method to do the rest of these questions. This is do it yourself. This is really important. This is really important. This is really important. It comes in this. It comes in the final. These two later came in the spring 2026 final, and I think that is enough from my side today. That is the end of chapter 10. And this is the end of chapter 10.5. I think so. So in let's just say end of the course of Math 211. This is basically the last video. This is the last video of the playlist, and we are done with this course. I hope you've enjoyed my videos, and I wish you the best of the luck in the future. And خلاص, bye bye. That is from my side.